In this video, I am going to do some calculations with vectors in component form, including finding the magnitude and the direction of a vector, such as this one. Alright, so let's get started. If I want to do negative 9u plus 2v, that would be like this. Negative 9 times vector u plus 2 times vector v. So I'm just going to do the scalar multiplication first. So multiplying by negative 9 will give me negative 81 comma negative 18, and then that'll be plus. Multiplying by 2 gives me 10 comma 18. Now I can just combine the corresponding components. Negative 81 and positive 10 make negative 71. Negative 18 and positive 18 make 0. So this would be the resultant vector for number 10. Alright, number 11. We have negative 3f minus 2g. Multiplying by the scalar here, I'm going to have positive 33 comma positive 15. Now, when I multiply the second one, please understand that I'm going to multiply by negative 2. Alright, I'm not multiplying by positive 2, I'm including the negative sign. And then whatever I get, I'm going to go ahead and add. So it's like I'm adding the rest of this. So I'm going to get positive 24 and negative 8. And now I will combine the corresponding components. So this is going to be 57 and 7. So this will be the resultant vector for number 11. For number 12, we have 6f plus b. So multiplying by the scalar will give me 12 comma 0 plus 3 comma 11. Adding the corresponding components will give me 15 comma 11. So this is the resultant vector for number 12. For number 13, we've got 6a minus 6v. Okay, so again, whenever I subtract, I like to put a little plus sign here to remind me that I'm going to actually distribute a negative 6, and then I'm going to add these two parts. So multiplying by 6 gives me negative 48 comma 60 plus, there's that plus that I put, and now I'm multiplying by negative 6, not positive 6, so I will get negative 6 comma negative 18. So this will give me negative 40, whoops, almost messed it up. This is going to be negative 54. Okay, negative 48 and negative 6. And then I will have, let's see, that would be 42. So this should be the resultant vector for number 13. Alright, so in number 14 we are to find the magnitude and the direction of this vector. I choose to draw my sketch in standard position, so I will need coordinate axes. So my vector n is supposed to go to the right 30 and down 5. That will put it into the fourth quadrant. So I'll just go ahead and draw it like this. And I'll go ahead and show the triangle that is made looking at the magnitude and the components. So this was right 30 and down 5. So what I can easily find, well, you know what, first I should go ahead and just find the magnitude. The magnitude is simply going to be the square root of 30 squared plus negative 5 squared. That's how you find the magnitude. So this is going to be the square root of 900 plus 25, which of course is the square root of 925. I'm seeing the 25 here, so clearly 925 is divisible by 25. A little four-function calculator action. 925 divided by 25 reveals that 25 goes in 37 times. So 25 times 37. 25 being a perfect square, this will become 5 radical 37. So wanted to get that out of the way. That is your magnitude. Now for the direction, this angle right here is the reference angle. It's not the actual angle that we're looking for. It's not the direction. But this is the angle that we can find first using tangent. The tangent of angle R should equal 5 over 30. Alright, and I'm just looking for the positive value here, so I'm ignoring the negative sign. So I'm just doing 5 over 30. That means R should equal the inverse tangent of 5 over 30, which by the way reduces down to 1 over 6. So might as well do that. So I'm just going to put this in my calculator. So let's do the inverse tangent of 1 over 6. Alright, 9.46 degrees. So that is my reference angle. Okay, now the actual angle that I want, though, is the angle that goes all the way around from the positive x-axis counterclockwise. Alright, so if I had kept going, I would have gotten to 360. So it's 360 minus r. So we will call the direction angle theta. So theta should equal 360 minus 9.46. That is 350.54 degrees. Oh look, they have spaces for us to write the answers. I didn't realize that. So the magnitude is 5 radical 37, and the direction is 350.54 degrees. Alright, so that was number 14. Let's do the same thing with number 15. Starting with the magnitude. The magnitude will be the square root of 12 squared plus negative 16 squared. So that'll be the square root of 144 plus, so we have 256. Add those up, you get 400. Take the square root, that's 20. So the magnitude is 20. Now let's find the direction. For the direction, we will need a sketch, or at least that would be very helpful. So 12 to the right and 16 down. So 12 to the right and 16 down again puts us in the fourth quadrant. Interesting. So I'm just going to draw my vector into the fourth quadrant. Alright, and then I'm going to show the triangle that is formed with 12 to the right and 16 down. So here we have the reference angle that we can find using tangent. So the tangent of the reference angle will be 16 over 12. So that means the reference angle will equal the inverse tangent of, I just feel like I should reduce this. If I divide both of these by 4, that'll be 4 over 3. So the reference angle is, and I'm just going to put this in my calculator. So the inverse tangent of 4 over 3. 53.13 degrees. Okay, now that reference angle is not the actual angle that I want. We want the direction to be measured from the positive x-axis counterclockwise all the way around to the vector. I will call that angle theta, and that's the actual direction. If I had gone all the way, I would have hit 360, so I stopped short. So theta should equal 360 minus 53.13. That is 306.87 degrees. Let's do a couple more. So let's see, magnitude. The magnitude is going to be the square root of -7 squared plus -1 squared. That's 49 plus 1. That's the square root of 50. 50 is 25 times 2. The square root of 25 is 5. So that leaves 5 radical 2 for the magnitude. Okay, now for the direction. This vector goes left and down. So that's going to put it in the third quadrant. So I'm going to draw a vector in the third quadrant like this. So this is left 7 and down 1. Alright, this is the reference angle that we can find. So we will say that the tangent of angle R is 1 over 7. Angle R will equal the inverse tangent of 1/7. So angle R, as we consult our calculator, is the inverse tangent of 1 over 7, 8.13. Now, the actual angle that we want is this angle that goes from the positive x-axis counterclockwise all the way around. I will call this angle theta. Now this angle goes all the way to 180, and then it goes an extra r degrees. So that means if I want angle theta, I should start with 180 and add 8.13. So of course that means that the direction angle is 188.13. Okay, let's do that one more time. Okay, let's start with the magnitude. Will be the square root of negative 46 squared plus 2 squared. That's the square root of 2,116 plus 4. That's the square root of 2,120. And this number is divisible by 4. If you do that, you find that 2,120 is the same thing as 4 times 530. 4 is a perfect square. The square root of 4 is 2. So that leaves me with a magnitude of 2 square root 530. So that is my magnitude. Okay, now what about the direction? For the direction, it helps to have a diagram. This is left and up, so that puts us in the second quadrant. So I'm just going to go ahead and draw my diagram into draw my vector into the second quadrant. I will make a triangle out of it around the reference angle. So this is my reference angle, and remember this was left 46 and up 2, drawing not to scale obviously. So I can use this to solve for r using tangent. So the tangent of r is going to equal 2 over 46. I'm ignoring the negative sign for this because I just want the positive value of r. So r will equal the inverse tangent, and this will reduce to 1 over 23. So calculator time. Inverse tangent of 1 over 23. 2.49. Got to round up. Okay, so that is the reference angle, but it is not the direction. The direction has to be measured from the positive x-axis. I will call it theta. If I had kept going, I would have gotten to 180 degrees. I had to stop short by r, so that means I should be able to find theta by taking 180 minus 2.49. And that is 177.51 degrees. And that's going to do it for this video, guys. Go ahead and click around this area for the next video, and click over in this area if you want to subscribe. Alright, feel free to mash that like button while you're at it.